Area and circumference of circles notes. Part 1. We're doing area of a circle and area of a sector today. Area of a circle should be familiar to y'all. Y'all seen this before. The formula for it: area equals pi r squared. For pi, and we'll use this throughout, we're going to use the number 3.14. We're not going to use the pi button on the calculator. We will use 3.14. They do the same thing on your EOC as well. You use 3.14. You do not use the pi button. You use the pi button, your number's going to be off a little bit. Now, I'll explain that to you when we do a problem. I'll show you what's up. R in that formula, R is the radius. You should know what a radius is. I'm going to talk to you about radius and diameter real quick, though, because surprisingly, some people don't be knowing. So I'll help you out one more time. So out to the side, we're going to make some notes so we'll know what a radius and a diameter is. Out to the side in this open area, let's go diameter first. Diameter is going to be the full length across the circle. Let me zoom in so I can see that. Full length across the circle. Radius. Half the length across the circle. Alright. So if you have one, you automatically know what the other is by doing simple math. It shouldn't be hard for y'all to figure out how to get one or the other. You gotta do a simple math to get one or the other. Alright, before we start, I want to talk about area itself, because some of y'all don't be understanding what area is. Area is the space inside of a figure. So when I'm talking about area, I'm talking about the space inside. All the space inside right here, the figure, that's my area. When I find the area of a circle, I'm finding all this space inside of it. I'm finding all this area in here. This is what I want to know. Circumference is the length around a circle. We'll talk about that tomorrow. So, finding the area of each circle at the top here, we're going to use the formula, pi r squared. If you ever get lost with it, it's up here on the wall on the left. It's been up there. I always rewrite the formula. It just helps y'all start to remember it. So I rewrite it every time. Area equals pi r squared. Then from there, A equals 3.14 times, what's my radius? 12 times 12. Listen to me on this, and I'm telling you this from experience, and somebody didn't believe me in first period and then made a mistake and realized that, maybe I should listen to Mr. Brunson. I write my stuff out. R squared means whatever your radius is, you're multiplying it by itself. I write it out like this so I know what I'm putting in the calculator. Don't be lazy with this and write 12 to the second power, because what you're going to do is on your calculator, all you're going to do is 3.14 times 12, and you're going to forget to multiply by the other 12. I guarantee you're going to do it. You're going to say you ain't going to do it, but I guarantee you are. I guarantee that in the second period, the kids are yelling out answers to me, and then I said, you forgot to multiply by the other number, didn't you? Like, yeah. You wrote a 2 on there, didn't you? Yeah. Listen to me. Write it out. Don't be lazy. Write it out so you know what you're putting in the calculator. That's 12 times 12. We round it to the nearest hundredths. 452.16. I suggest, even if we give answers, I suggest y'all put this in the calculator so you can see it in the calculator. Alright, sliding over. Number 2, area equals pi r squared. So 3.14 times Reese. What's my radius? I knew I asked the right person. 17.5 is my radius. Anybody got any confusion on why that is? I'm writing into my other words, my bad. Sorry, that's 17.5 times 17.5. I should have moved that over further. What we got? 961.63. This is kilometers squared. Let me show y'all something too. So the reason we use 3.14, like you have to make a decision on here. You can't go back and forth. You gotta be accurate with this. So the actual decimal for pi is a long repeating decimal. If you look at that poster over there, it shows you like most of it. It just keeps going. Y'all see the one over here on the left? The pi equals 3.14, 1 to 5, 9, whatever. There's a kid out there that actually remembered most of that. I seen him do it on TV one time for no reason. That's the accurate number for pi. But we don't always use that because nobody about to type that in every time. So we just use 3.14. It's fine if you're going to use 3.14. You just can't bounce back and forth. Decide to use 3.14 for one question and pi for another one. In geometry, for us, we use 3.14. We don't ever hit the pi button. So if you start using pi, you're going to get all your answers wrong. We're going to mark them wrong too because we're using 3.14. Let me show you the difference though, how far off you'll be. So we use 3.14 and we got 96.961. If you use pi, so if you say 17.5 times 17.5 times pi, you're going to get 962.1 whatever. These numbers are not going to be that close to each other. Alright. So we're using 3.14. I know. So that's just basic area. Area is easy. Y'all need to know area of a circle though. You're going to need that for when we do composites later next week. Area of a sector. Similar concept, is just now you're not doing the entire circle. You're just doing a piece of the circle. Area of a sector, or a sector, is a portion of a circle bounded by a central angle and its intercepted arc. Think of a sector like a slice of pie or pizza. So I'm going to explain this before I go. Hopefully I give you the best explanation I can on this. So we're not looking for the area of the entire circle anymore. We know how to find that. We did that up top here, 1 and 2. We only want to know the area of a piece of a circle. Slice. That's a sector. The shaded area. I want to know the area of that. To know that, they would need to give me either the central angle, which is an angle coming from the center of the circle, or the arc that it intercepts, which is up here, and they're both the same. So they got X on both. Both of these will be the same. If my central angle was 60 degrees, then my arc would have to be 60 degrees that it intercepts right here. Both of these are the same. The central angle inside and this arc on the outside. Just checking with y'all. What does a circle add up to? 360 degrees, right? So we don't want to know the whole area of the 360 degree circle. We only want to know the area of this angle, or this slice of the circle. So that's why we would need that angle. Alright. The formula. And we use the variable k. in our formula. Now I know we used K before this. We use K for scale factor too, but we also use it for area of a sector. K equals X over 360 times the area of your circle, which is pi r squared. Let me explain to you what the formula is doing too. So first you're going to find your area of your circle like we did up top, but then you're going to multiply it by whatever portion of that circle that you're actually trying to find the area of. So you're basically multiplying it by a fraction so you can get what fraction of the circle you're getting. To set up that fraction, you always do it over 360 because the whole circle equals 360. And you just want to know what angle out of that circle you're trying to find the area of. So if I do 60 over 360, that's going to give me the fraction of the circle that'll be this shaded area right here, if this was 60 degrees. And multiply that times the area of the circle, that would give me that area of that shaded region. Hopefully that kind of makes sense to you. We're going to do it down here. So you already know this stuff to the side. It says X equals the degrees of measure of the arc. R is the radius of the circle. Down here, we're going to find the area of each shaded sector, round to the nearest hundredth. Number 3. On this one, the first thing they tell me is BC equals 16. Let's see here, BC equals, that represents what, my radius or my diameter? Radius, so that's basically telling my radius equals 16. I need to know that. So my formula is going to be K equals X over 360 times the area of the circle, which is pi r squared. And then I'm plugging in what they give me. K equals 51 over 360 because it's 51 degrees. That's the degrees of my slice. Times 3.14 times 16 times 16. How you want to do this in the calculator? Do the fraction first. Get the decimal. Then multiply by everything else. What? You don't have to simplify unless they ask you to keep your answer in. And I don't think we ever do that in here. It's a form they ask you to keep your answer in sometime. I think they call it in terms of pi. If they ever ask you that, then you have to simplify the fraction, do all that other stuff. But in this case, you don't. We just want the full out answer, so you can just give me decimals and everything. So let me show you how I would put this in the calculator if I was you. 51 divided by 360. That's going to give me my decimal right there for this fraction. Then times 3.14 times 16 times 16. Round it correctly, what would this be? 113 point what? 88. It's okay, but I'll do that right now. Number 4, sliding on, y'all probably ahead of me. PQ in your radius is 22. $139 is your angle. 360 times 3.14 times 22 times 22. Whenever y'all get it, y'all can let me know. Got it around correctly. Make sure y'all see that in the calculator. Try it in the calculator for yourself, please. Pay attention to how we round it. Yeah. Maybe. Sometime. If today B day, then he should be here. No, today A day, so I guess he ain't coming. Supposed to come yesterday. Patience with it. Yes, I know it. Alright, 7. It's 5. I'm tripping. Looking at the number, that's 7 centimeters. HG equals 7. Make sure that is your radius, which it is. I don't know why I'm writing 7 centimeters, but whatever. K equals x over 360 times pi r squared, which is my area. So K equals, Reese, what's x? What's my degrees? Somebody say something intelligent. Thank you. 46 plus 46. You should all be able to see that. 92 degrees over 360 up times 3.14 times 7 times 7. Thank you. Faith, round it wrong. Sliding over one more. Challenge yourself. I got you. I'm gonna have you set up with me. Challenge yourself on this one. Radius is PC, so that's R is 12, and so K equals x over 360. I always write it out. The more you write it out, the more you remember it. These will not be given to you on no reference sheet either, so you have to remember these. Alright. You're saying 186, but that's wrong. Vincent, how you find your angle for your shaded region?
62 times 3 minus 360.
Good. So he said 62 times 3, which is true because all these are 62 degrees. That's going to give you 186, but then the key part about that, that's my non-shaded region. I need my shaded area. So like Vincent said, once you get 62 times 3, you need to subtract that from 360. So 360 minus 186 is 174. Now kids last class are like, oh, then you divide by 3. What's the point of dividing by 3? There's no point, is there? Do I need to know each individual little thing? No. I want to know what all of them are together anyway. So 174 is what I'm going to roll with. Alright. Then from there, times 3.14 times my radius, which is 12 times 12. K equals. Go ahead. Thank you, sir. This is centimeters squared. Alright, so that is area of a circle and area of a sector. I want to just focus in on that with y'all for today. Tomorrow we'll do part 2, which is going to be circumference and arc length.